Hello everyone.
Now, another important point to be remembered while we are talking about these things is you should be able to clearly differentiate between what is a regressor variable and what is a response variable. A regressor variable might also be called as predictor variable. Okay, these two are kind of equivalent words, regressor variable or predictor variable and a response variable. Now you must be thinking that we are not that dumb that we don't know how to differentiate between regressor and response. I know you all are good, but still there can be some tricky situations where it may become difficult to define what is a regressor and what is a response. Or sometimes you may end up forgetting that a response is created from some other variable, and if you input that variable in, things are going to get bad. Okay, so I can give you an example. I had given kabaddi data, I think. Okay, yeah, wait. Football, it's easy to understand. So if I consider say football or cricket, something like that, things are generally easy to understand. Cricket is further easier. Okay. So if I am considering cricket matches and I am recording, for every team the runs that they have scored, so it's their own score, then runs that they conceded, wickets which they lost or wickets which they took, and so on. Now if I give you an Excel sheet with these columns, runs scored, runs conceded, wickets lost and wickets taken, and so on, and then finally my outcome is, so this I will give for both the competing teams. Okay, so suppose I have data for team 1, all these variables, then I have data for team 2, all these variables in a say particular series, like the World Cup. And now here you have outcome of the match. Outcome of the match is 0 if T1 fails, T1 loses the match. Outcome of the match would be 1 if T2 loses the match, that is T1 wins. Okay. Now if I give this data set to you and I say okay, try to develop a model which can help me predict outcome of a match. Okay, so what I ideally expect is you use the variables from T1 and T2 and try to come up with a rule. Now what we have in T1 and T2, runs scored, runs conceded, wickets lost and wickets taken. Now if we compute runs scored minus runs conceded, you actually get a perfect fit, because if runs scored is greater than runs conceded, then of course that party is going to win. That team is going to win. Okay. But I cannot really use run scored minus run conceded as a variable, because it's not really a regressor. It's actually just another form of response. Your response variable is just a recoding of this difference. So from this difference you have just computed an indicator variable. If this difference is greater than 0, you give 1 as a value to that indicator function, and if the difference is smaller than 0, then you give value 2 to that response. So basically these are used in construction of response. So in such scenarios you have to be very careful, because if you simply use some standard algorithm that is available in the software on this data, software would come up with this as the best predictor, runs scored minus runs conceded. Okay. Now, so it is very important that you know the relationship between regressor variables and the response variables. Don't mix. That's why I am saying that even if it seems very easy to distinguish between regressors and response, it need not always be the case. Here in cricket example, it was easy to understand because cricket is something that we grew up watching. But if you are looking at some other domain, it may not be that obvious and you might end up making the same mistake. That is using the response in other form as regressor. And you would unnecessarily be happy of having a good fit, but it would really not matter at all. Okay.
Thank you.